Welcome to this series of lectures about the resolution of linear systems. So in this lecture we are going to present you a method to solve a linear system which depends on some parameters, maybe one, maybe more than one, but the idea is always that the method is based on the Gauss algorithm. So let's start with an exercise where we show how the method works. So we want to solve a linear system which depends on a parameter a, which is a real number. And the linear system is the following. So we have three equations. The first one is x plus ay minus z equals a. The second is 2x plus 2ay minus z equals 3a plus 1. And the last one is x minus 1 plus az equals 2. So the idea is that as the system depends on the parameter a, we might expect that the number of solutions and actually the values of the solutions will really depend on the parameter a. So maybe for some particular values of a, the linear system will have no solutions. For some parameters a, the linear system will have only one solution, and maybe for some other parameters, for some other values of the parameter a, the linear system will have an infinite number, infinitely many solutions. So how does the method work? We want to use the Gauss method. So the first thing you want to do is that you want to associate to the linear system a matrix which forgets about x, y, and z. So the idea is that we start with the linear system, and now we associate to this a matrix which somehow isolates or somehow preserves only the coefficients of x, y, and z, and adds a further column which is the right-hand side of the linear system. So the first column is going to be 1, 2, 1, which are the coefficients of x. The second column is a, 2a minus 1, which is the coefficients of y. The third column is minus 1, minus 1, minus a, which is given by the coefficients of z. And the last one is a, 3a plus 1, 2, which is the right-hand side of the linear system. Now we want to use this matrix in order to resolve the linear system. And we use the Gauss method, the Gauss algorithm. And so the first thing you notice is that the first entry of the matrix, namely the one which lies on the first row and on the first column, is a 1. And so we use it as a pivot. Recall that a pivot is always one of the coefficients of the matrix which is non-zero. And this is very, very important for the remaining part of the exercise. So for the moment we choose this 1, and we want to use this 1 in order to erase the 2 and the 1 which lie on the same column where 1 lies, so the first column. So in order to do that, we subtract twice the first line to the second line, and the first line to the last line of the matrix. And what we get is that the first row of the matrix remains unchanged, while the second and the third get some modifications. So the first coefficient of the second row is 2. You have to take 2 minus twice 1, so it's 2 minus 2, and you get a 0. For the second is 2a minus twice a, so it is 2a minus 2a, which gives you a 0. And you have minus 1 minus twice minus 1, which is minus 1 plus 2, which gives you a 1. And then you have 3a plus 1 minus twice a, so it is 3a plus 1 minus 2a, and it gives you a plus 1. For the last row, you have 1 minus 1, which gives you 0. You have minus 1 minus a, which gives you minus 1 minus a. Minus 1 minus minus 1, it gives you minus a plus 1. And finally 2 minus a, which gives you simply 2 minus a. So this is now the matrix you have produced after the first step of the Gauss algorithm. Now recall that the aim of the Gauss algorithm is to reduce as much as possible the matrix we started with, and that means that we have to use now another pivot in order to get a simplification of the matrix using some elementary transformations which are allowed in the Gauss algorithm. So we have to choose a second pivot, as I said, So we start again with the matrix we produced in the last step. So it is 1, 0, 0, the first column, a 0, 1 minus a is the second column, minus 1, 1 minus a plus 1 is the third column, and a plus 1, 2 minus a is the last one. So now we look at the matrix and we see that on the second line and the third column it lies a 1. So we use it as a new pivot. Recall that is in the Gauss algorithm, once you've chosen a pivot on some particular line and some particular column, then you cannot use any longer that column and that row to choose the new pivot. So now we use this 1 in order to erase the entries which lie on the same column, so the minus 1 above and minus a plus 1 below. And so the idea is that we modify the first line by adding to it the second line, and the last line by subtracting to it minus a plus 1 times the second line. So what happens now is that the second line, the second row remains the same, so it is 0, 0, 1, a plus 1. And now the first line, the first coefficient is 1, you have to add the first coefficient of the second row, which is so 1 plus 0, so you get a 1. For the second you have a plus 0, which is a. For the third you have minus 1 plus 1, which gives you a 0. And for the third you have a plus 1, which is 2a plus 1. For the last row you have 0, you have to subtract minus a plus 1 times 0, so it is 0 minus 0, which gives you a 0. Then you have minus 1 minus a minus a plus 1 times 0, so it is minus 1 minus a minus 0, so it is minus 1 minus a. Then you have minus a plus 1 minus a plus 1 times 1, so it is minus a plus 1 minus a plus 1, so it gives you a 0. And for the last row you simply have 2 minus a minus a plus 1 times a plus 1. So now let's do the calculations for the last entry, and you get that the last entry is 1 minus a plus a squared. So this is the output of the second application of the Gauss algorithm. Now, there is still one possible pivot which is left, which is minus 1 minus a. So recall that we already used the first row, the second row, so we can only use the last row, and we already used the first column and the last column, so it is only the second column which is possible to left, which is left. And so the only possible pivot we have is minus 1 minus a. But now recall that a pivot can never be 0. So this implies that you have some conditions on a. And so let us discuss the possible cases we are left with. So the situation now depends on the value of a. If minus 1 minus a is 0, then we cannot choose minus 1 minus a as a pivot, while if minus 1 minus a is non-zero, then we may choose it as a pivot. So we need to divide into we need to split in two cases. The first one is when a equals minus 1. So if you replace this value in the previous matrix, you get the first column minus 1, 0, 0, the second column is minus 1, 0, 0, the third one is 0, 1, 0, and the last one is minus 1, 0, 3. So if you now look at the last row of this linear system, you get 0x plus 0y plus 0z equals 3, which gives you 0 equals 3, which is not possible. And so in conclusion, when a equals minus 1, the system can have no solutions. We are now left with the case a different than minus 1. So in this case, you look at the matrix, and now minus 1 minus a might be chosen as a pivot, and we need to use it to delete the only non-zero entry on the column where minus 1 minus a lies, that is the second column. And this entry is the a which lives on the first row. So in order to use minus 1 minus a to erase this a, we need to replace the first row by 1 plus a times the first row plus a times the third row. And if we do this, then you see that the second and the last row remain unchanged, while the first row gets modified in the following way. So first of all, this 1 has to be multiplied by 1 plus a, so this gives you 1 plus a, and to this we need to add a times 0, which is 0. So in the end you get 1 plus a. The second entry gets multiplied by 1 plus a, so you get a times 1 plus a, and to this you need to add a times minus 1 minus a. And so you are subtracting to a times 1 plus a times 1 plus a, and you get 0. For the third entry of the first column, you have 0 times 1 plus a plus 0 times a, so in the end you get a 0. And for the last entry, you simply have this expression, which is 2a plus 1 times 1 plus a times 1 minus a plus a squared. You do the calculations and you see that the last entry of the first row is 1 plus 4a plus a squared plus a cubed. So now you do a slight modification again of this matrix in order to get in its reduced form, and to do this we need to switch the second and the third row. So this is the operation we are going to do now, and this is very easy to do, so you just rewrite the third row as the second and the second row as the third, and you get the following matrix. So you now see that the entries which are in a box are all different than 0, because we suppose that a is not minus 1. And so 1 plus a is non-zero, minus 1 minus a is non-zero, and 1 is always non-zero independently on the value of a. So, in conclusion, you see that this linear system has only a unique solution, which is the following. X is 1 plus 4a plus a squared plus a cubed divided by 1 plus a. Y is minus a squared plus a minus 1 divided by 1 plus a. And z is simply a plus 1. So, we can now conclude with the resolution of the linear system. In the end, the linear system we started with has no solutions for a equal to minus 1, and a unique solution for a different than minus 1. And this solution is exactly the one we found in the previous slide.